If we look at a second example, this example sometimes, this is an example of a problem that tends to throw students off because this is really one of the first times that we have to be extremely careful about the directions that are present in the problem. In the past, there were a lot of times where if you forgot the direction, it was just a matter of saying, oh, let me just throw the negative on there. This is not really the case anymore. The entire time I've been saying we have to be careful about vectors and direction, and it's going to come back to bite us if we're not careful. This is really the first experience you're going to have where you will get bitten if you try and solve the problem without accounting for direction properly. You'll start to get the actual wrong answer, and that will eventually snowball into future wrong answers, and that will make physics much harder to understand. So in this case, we have an object that's rolling northward at 4 meters per second. And 8 seconds later, it's traveling at 12 meters per second in the opposite direction, southward. So over those 8 seconds, something must have been pushing this object to the left because it was traveling right and now it's traveling left. So something came along and gave this thing a whack to the left over the course of 8 seconds. And the question asks us to determine what was the acceleration that occurred during those 8 seconds that changed this object's velocity from 4 meters per second north to 12 meters per second south. So, like we did previously, we're going to list out the variables that are in our acceleration equation, but we're going to be extremely careful. So right now, I have a north for my initial velocity and a south for my final velocity. So we need to determine which direction will be positive and which will be negative. It does not matter which you assume as long as you're consistent. In this case, I'm going to use convention and assume north is positive and south is negative. So because my final velocity is 12 meters per second south, I'm going to note that as negative 12, okay? The negative signifying it's going to the south. The initial velocity is 4 meters per second to the north, so I'm going to signify that with a positive 4. Once again, the acceleration is the unknown quantity, and I'm told that the time that elapses is 8 seconds. So at this point, if I've accounted for my directions correctly and I have all the right values, I can take out my acceleration equation, plug in what is known, and in this case, the final velocity is negative 12, and I'm subtracting from that a positive 4. That gives me a total of negative 16 in the numerator, divided by the 8 in the denominator, gives me negative 2 meters per second squared. While I will accept negative 2 meters per second squared, it is a little bit better to go one step further. And back in the beginning of the problem, I noted that south was negative. So the fact that I get a negative answer just tells me that it is 2 meters per second squared to the south.